Today we're looking at lesson 2.6, which is multiplying and dividing rationals or rational expressions. Let's take a look at some warm-ups. So this is what we should have remembered or discovered last day when simplifying and stating restrictions. So simplify and state the restrictions. So ladies and gentlemen, looking at 1A, if you're wondering how I broke down these factors, for the first one, ladies and gentlemen, on a side margin, you can realize, hey, the numerator is a decomposition, so the product equals A times C, which is 18. The sum itself is 11. What two numbers meet that? That's 2 times 9. So then I'm going to split the middle term. So it's going to be 6x squared plus 2x plus 9x plus 3. Then I'm going to factor by grouping. So what's common in the first two terms? It's 2x. So you're going to have 3x plus 1. And what can I take out of the last two terms? 3. So we have 2x, sorry, my fault, 3x plus 1. So again, the common binomial is 3x plus 1. And the leftovers is 2x plus 3. That which is then put in here. So again, guys, factor on a separate margin, so then you can just simply put the factors down. Otherwise, you're going to be writing these expressions and using much more space than you need to be. Once you've got your fraction, your expressions factored, the denominator is a simple difference of squares. You look to cancel or reduce. So in this case, we can cancel out the 2x plus 3, and what we're left with, ladies and gentlemen, is 3x plus 1 divided by 2x minus 3. Taking a look at our restrictions, we go back to the original one. The one that's canceled out is this one, and remember, when you cancel out, that's a whole, and when you have a factor that remains and you can't cancel it out, that becomes your vertical asymptote. Although it doesn't ask for it, I just wanted to make sure that you mastered that skill from last day's lesson. Looking at example B, ladies and gentlemen, we notice that we can common factor in the numerator, so 3m goes into both terms. And then the denominator, ladies and gentlemen, there's a little bit more work you need to do for that. So again, on a side margin, I'm going to common factor out an m, and then I'm left with m squared plus 4m plus 4. Looking inside that denominator, in the denominator inside the bracket, I realize that's a perfect square. So it's going to be m is our common factor, and then m minus 2 times m minus 2. Taking a look, once we've got our expressions factored, then we look to cancel or reduce. And in this case, we can cancel out the m minus 2 from both the numerator and the denominator. So our final answer is 3m divided by m times m minus 2 in brackets. Taking a look at our restrictions, ladies and gentlemen, m cannot equal 0, okay, which is a whole, because it got canceled out. Sorry, my fault. I apologize for that. Yes, my fault. You can cancel that out. So I forgot to just throw my last step in here. So it's going to be 3 over m minus 2. I apologize. So the m cancels out, so we call that a whole. And the 2 kind of is a perplexing thing. You can argue, Mrs. R, it canceled out and it remains. But when you always take a look at your final expression, that's going to lead you with the vertical asymptote. Although it was initially a whole, the vertical asymptote is kind of like your second step, or it trumps the whole factor. All right. Any questions with the warm-ups, please come and see me. Today, ladies and gentlemen, we're focusing on multiplying and dividing rational expressions. When multiplying, you can cancel common factors within a fraction. And within a fraction, you may have heard that word called reducing or reduce, or across a multiplication, i.e. you have to have a numerator from one and a denominator from another. Just remember, guys, when dividing, you flip the second fraction and multiply. Looking at example A, I select to use different colors so you can see what's going on here for the canceling. Okay, looking at example A, ladies and gentlemen, you could multiply everything together, or you can cancel it out right away and then factor it and then simplify it. My fault. So either method, you could multiply first like we do right here. But what I prefer is to just say, hey, before I multiply, what can I cancel out to make life easier for me? So looking at this expression, I'm left with a to the power of 3 divided by 1, which just equals a to the power of 3. Now to look for my restrictions, ladies and gentlemen, I go back to my denominators. And again, we look at, but we have two denominators here to look at. So a cannot equal 0 and b cannot equal 0. And remember that since they've canceled out, these are both wholes. That's why it's a restriction, because they're both wholes. Looking at B part, the main thing you've got to remember before you do any canceling out is you look at the sign. The sign here tells us to divide. So you need to rewrite that and invert or flip the second fraction. So you will notice that the numerator and the denominator have switched here. Okay, and it's now multiplication. Then you can look to cancel and reduce. I always start with the numerical coefficients first. So 13 goes into 13 once, it goes into 26 twice. Then I look at my other numerical coefficients. 5 goes into 5 once, and it goes into 25 5 times. Then what I do is I try to deal with my variables in alphabetical order. So I've got x to the power of 3 and times x to the power of 1. So I've got a total of x to the 4th on the top divided by x to the 3rd. So I'm just going to cancel out x to the 3rd with these two. Okay, and then I look for my y's, and I notice I have the same number of y's on the top as I do on the bottom. So it's the 7th power. Just remember, guys, your exponent laws. When you're multiplying bases that are the same, you add the exponents. Okay. So they will cancel each other out. And so what we're left with when we simplify is 10x divided by 1, which leaves us with 10x. What we need to do for our restrictions is it changes here, ladies and gentlemen. We need to not only look at both denominators in the original question, but we also need to realize that this equation gets flipped, ladies and gentlemen. So for restrictions, you got to be careful here. When dividing, I'll write this in, when dividing, you have to look at old and new denominators. Okay, and that's where your restrictions are going to be. Okay, that's going to play a big role as we get further down in the lesson when we get some bigger expressions. Okay, so just remember, when dividing, look at the old and new denominators. Okay, and again, when we look at this, ladies and gentlemen, since x and y has both been canceled out in the denominator, that tells us that these are both wholes. Though it doesn't ask you for it, I just wanted you to think about that and consolidate last day's lesson. All right, looking at C, ladies and gentlemen, we can easily notice that we got a binomial here. We can cross them out. Okay, so the x minus 2 and the x minus 2 gets crossed out. And then we look to simplify. Excuse me for that interruption. Okay. And we can simplify, 2 goes into 4 twice, 2 goes into 1 twice, and then you've got x squared and x, so you just end up with an x up top. So what we end up when we simplify here, we end up with x divided by 2, and we have to look for our restrictions. Go back to the original expression. Here we will notice that x cannot equal 0. And here we'll notice that x cannot equal 2. And again, since both have canceled out, both of these are wholes. All right. Okay. Taking a look, ladies and gentlemen, at D, we're getting a little harder now. Although this is still in factored form, we still have to watch how we cancel, and we also have to watch the operation in between the two rational expressions. So again, notice before you cancel, ladies and gentlemen, that there's a division sign, so you need to invert or flip the second fraction, and then you can cancel. So taking a look at our canceling, ladies and gentlemen, we notice that x plus 1 can get canceled from both the numerator and the denominator. So the exponent of 2 changes to a 1. And then we And then we will take a look at canceling out x plus 2. What does that leave us with? Leaves us with x divided by x plus 1. And now for our restrictions, we've got a lot to deal with. First of all, our first restriction here, x cannot equal 2. The second one is x cannot equal 0. And don't forget the flip here, guys. You got to look at this one. X cannot equal negative 1. Just remember which one exists still. Okay, the one that still exists is the negative 1. So that tells us that's a vertical asymptote. Whereas the other two, look at the denominator. This one is a whole and a whole. Okay? All right. All right, I apologize. The 0, since it still occurs, is going to be a vertical asymptote, and the one that cancels out is going to be your whole. All right, just remember, I wrote that out already. When dividing, we must consider the denominators old and new. Excuse me. All right, let's take a look here at E. Now we're going to be doing some factoring. Again, if you need to do factoring on a margin, please go ahead and do so. Please follow along the pathways here, guys. So looking at our first denominator of our first fraction, that's a common factoring. Okay, looking at our denominator of our first fraction, that is a difference of squares. Looking at our numerator of our second fraction, that is simple trinomial factoring. And the denominator of the second fraction, that is your perfect square. Okay? Once you've factored all of your expressions, then you look to cancel. So what we have left here, ladies and gentlemen, is the simplified result right here. Then we have to look for our restrictions. And again, looking at the denominator here, we notice that first of all, x cannot equal negative 3, and that's a vertical asymptote because it still remains. X cannot equal negative 2, or cannot equal 2, so that's a vertical asymptote. And the one that got canceled out is x plus 2, so that's going to be y, x cannot equal negative 2, and that's going to be a whole. All right. Questions with that? All right. Moving on, this is the last question and the most difficult, ladies and gentlemen, because you're going to be doing some decomposition. So again, you're going to do decomposition here. Please note the sign, so you want to probably write it out with it flipped, okay? So you do decomposition here and here. This is a perfect square, and this is a difference of squares. All right, so on the side margin, do all your factoring that needs to be done, and then you produce these products. You look to cancel, and so we ended up with 3m minus 1 over 2m minus 1. Again, to look for your restrictions, you've got to deal with both the denominators in the original expression as well as the numerator that gets flipped to become the denominator. So in this case, x cannot equal negative 2 over 3. That's a whole because that one gets eliminated. Okay, x cannot be equal to negative 1/2 because that's a whole. And x cannot equal 1/2. That's the one that remains, so that's a vertical asymptote. All right, ladies and gentlemen, that is it for today's lesson. When you're doing your homework tonight, it's page 122, numbers 4 to 7, A to B only for 4 to 7, so please watch that. 8 to 10, and 11 and 13 is a challenge. I will tell you 13 will probably take you a half a page to do. So I would give that a try if you can and see if you can compare it with the answers that I have in class. All right, have a great day and thank you for listening.